in vivo converting a cell. So let me elaborate on that a bit, because this is something that my laboratory described for the first time a few years ago, and now I think you'll see this paradigm will likely apply to many, many tissue injury in the body. So you all have heard about the notion of taking a stem cell in a dish, let's say maybe even a heart cell, and then injecting that into the heart to try to create new heart cells, because after you have a heart attack, the heart can't regenerate itself and you're left with a damaged heart. That leads to heart failure, and there are 23 million people in the world with heart failure, and there are very few heart transplants done that are available. And so the 2-year mortality for end-stage heart failure is actually 50%, and we don't have any treatment for it. So it turns out that the human adult heart, every heart in this room, is only half muscle. And the other half of your heart are these support cells that we call fibroblasts that are just sitting there, never meant to be muscle, but they're in the organ. So we asked, if we can control cell fate at will, like I told you, then maybe we could take those fibroblasts that are already in your heart, after you've had a heart attack and you have a big dead muscle area, and what if we could convert those fibroblasts already in your heart into brand new muscle without ever having to put any cells in? That would be fantastic, because it's your own cells. They're already there. We don't have to put them in and get them to survive and integrate and all those things that would have to otherwise happen. And so we've been able to do that in the last few years. So far in animals, we've found that a cocktail of just 3 factors are powerful enough to reprogram the non-muscle cell in your heart directly into a muscle cell. And that muscle cell not only turns into muscle, it beats, it integrates with its neighbors, because that's critical. It has to beat in unison. The heart beats all at the same time. So they electrically connect. And in mice, we've shown that when you put these little mice in an MRI machine, which we have for little mice, we sedate them like we do people, that their hearts beat with greater force and can pump more blood after we've injured them, mimicking a heart attack, if we can reprogram their cells. So that's been very encouraging to us in the field. And we've now moved that into pigs, because their heart is bigger and more similar to our hearts and in size and physiology. And so far now it looks like, and we're actually working with Al Chin, who's one of our friends here at Gladstone, is helping us with some of these studies. And there it looks like we're getting quite good reprogramming in vivo in the pig heart with this strategy. And now we're doing MRIs on the pigs to see if we can really make a difference. And if that works, then we would move this further into clinical trials. We think this approach is not only going to be effective for the heart, but almost every tissue in the body has these support cells nearby that could be called upon if we knew enough about those cells to change their fate and reprogram them. And so I think you'll hear a lot more about this going forward, but this is a brand new technology. It's moving fast. And again, it represents one of those sort of next generation things that we couldn't even have dreamt about doing a few years ago. So we're really excited about that, and we wanted to share that advance with you guys here today.